welcome to another video in the Day Skipper course series. In this video, I want to talk to you about magnetic compass, variation, deviation, and what that is, how it affects our compass, and how we need to be aware of that in order to calculate how to steer our boat and which way we're going to go. So the first thing we need to talk about is variation. If I were to draw a small globe here like this, with a north and a south pole and an equator, we can see that this is the true North Pole, this is the true South Pole. And on our charts, all of the lines that we see going up and down and side to side refer to true North, true South, true East and West. The problem that we have as small boat sailors is that we use a magnetic compass. On larger vessels, you have something called a gyro compass. A gyro compass will automatically point you true north and south, east and west, and we don't have to worry too much about navigating with magnetic compasses, although all large vessels still have magnetic compasses as backup, but we're fortunate in that we can use gyro compasses. Unfortunately for small boat users, gyro compasses are very large pieces of bulky equipment that use a lot of electricity, so we have to rely on a magnetic compass. Problem for us is that a magnetic compass, unfortunately, does not point to due north. True north. A magnetic compass currently at the moment is pointing off somewhere over here, as it were, maybe the other way around to do it. So if I was to have my compass here, it would actually point like that. The reason for that is that the magnetosphere of the Earth is not aligned directly, truly, north and south. It is aligned more or less like that at the moment. These are the magnetic lines. The other problem we have is that this magnetic north doesn't stay where it is. It moves around. Fortunately, it doesn't move very fast, but it does move around, and we need to be aware of that. And there are ways that we can. This is how much it moves and where it is has all been calculated for us, and is depicted on our charts, on our magnetic rows, so that we can easily, with a small equation, work out the difference between true and magnetic. One other thing I want you to be aware of here about this, though, is that it depends entirely on where I'm standing on the globe as to what the difference between true and magnetic is going to be. So the angles of difference of variation between true and magnetic vary quite dramatically depending on where you are on the globe, and you don't have to be that far apart to make a little bit of a difference. So if you were doing a long ocean passage from west to east or east to west, you would find that variation would change quite a bit going from one side to the other, and if you're using a magnetic compass, clearly you'd need to be aware of that. And on a daily basis, just make sure that you update it if you need to. So that is something called variation, the difference between true north and magnetic north is variation. Let's look now at deviation. Deviation is slightly different. It's something else that affects our magnetic compass on our vessel, but it's nothing to do with outside influences. If I was to just draw a little picture of a boat here, on our boat we have an engine and we've got an anchor. We might have a load of stuff stored in our locker over here, metal things in our locker. Perhaps somebody's fitted a stereo system in there like that. Maybe if there's a shelf here, if your compass is mounted here, perhaps there's a galley section here with some metal things behind it. All of these accessories, if you like, metal accessories, and perhaps some of them are magnetic. For example, the back of a speaker, a stereo speaker, is very magnetic and would pull a compass around. And what these do is they deviate your compass, and that causes deviation. That deviation is in one direction only, specific to the boat. As you turn your boat then through 360 degrees of circle, as you move around, The amount that it's deflected doesn't change, but the relationship to that deflection and your heading changes. So you end up with a deviation, let's say going north of 0, let's say there's nothing 0, and a deviation going south of 0. But if you're going east and west, let's say there's a deviation of, say, 8 degrees this way and 8 degrees this way. Now you would probably end up, what you can do is draw a deviation card out, and all boats should have a deviation card on them. You would get a professional person to do a compass swing for you. You can have a go at it yourself. I'm not going to tell you how to do that now, but it's easier to get a compass swinger to come and check your compass for you and draw you a deviation card. Often look a little bit like this, with the amount of deviation in degrees up to sort of 0 up to, say, 10 degrees, whatever, 0 to 10, west and east. And depicted this way, your 30 degrees, 20, 60 degrees, 90 degrees, 15, 20, 180 degrees, all the way around as you go through your circuit. So you can see that whatever you're heading, you can then cross-reference your deviation. We use a slightly different deviation card, and you'll see this in your course notes. It's actually in your sample chart work questions, day skipper questions, right at the very beginning, is this deviation card, which we're using. It looks different to this, but don't worry about that. It works in exactly the same sort of way. Here we have the compass courses going around, and there's the relevant deviation on those courses. This column here shows magnetic, and you'll see how that works in just a moment, the correlation between those two, when we come to do a calculation to work out what our deviation is, or to work out what we should, how much deviation we should factor into a course to steer.